Welcome to MRU E-Learning, forward by Malla Reddy University. Myself, Lakshmi Bhargav, Assistant Professor, Department of Data Science, School of Engineering, Malla Reddy University. Today, I am going to deliver a session on algorithmic approach to searching linear and binary techniques. Introduction to searching. Searching is the process of finding a specific element called key from a collection of data. So we have a group of elements in an array or in a database. So if you want to find a specific element from that list, we have to use searching techniques. So it is one of the most fundamental operations in data structures. We know data structures are very important to store the data, to perform operations on the data. Like searching is used in many real life applications such as finding a record in the database, searching a contact in a phone, searching data in files and software systems. So for example, if you take one example in our mobile phone, so if you want to call a particular person, we have to search with their name. So there is also a data structure, and that is called some searching technique. So efficient searching improves performance and reduces time complexity. So some commonly used searching techniques are linear search, binary search, hashing, tree-based searching, and graph searching. There are many searching techniques used in data structures depending on the type of data and applications. So among these, linear search and binary search are the most basic and fundamental searching techniques. So this is first one is the linear search, second one is the binary search. These two I am going to explain in today's session. So first one is linear search. So linear search is the simplest searching technique among all the techniques. In these methods, elements are checked one after another in the array. It will start from a first element. The search continues until the required element is found or all elements are checked. Linear search works both sorted and unsorted arrays, but it is very slow for large data sets. So this is the algorithm for linear search. So first we have to start with the array, read the array elements, and we have to fix one element as the target element. The target element is called, we can say it as key. So in array, we know the index will start from 0. So, and it ends with size minus 1. For example, if you take one array, and this is one array, and here some elements are there like some 7, 3, 12, 13, 8. So these are the elements. And if you call this array name as ARR, array, some array name, so the index of the first element will be like ARR of 0, 1, 2, 3, 4. So here our array size is 5 because here total elements are number of elements are 5. But our array index starts with 0 and ends with size minus 1. That is nothing but 0 to 5 minus 1, that we can say it as 0 to 4. That index starts with 0 and ends with size minus 1. This is array. So here elements will be there. And we have to take one element as a target element. That we can say it as a key. So which one we are calling it as a key? So which element we are going to found in particular array, that we can say it as a key element. So here repeat the steps from I to n. That is nothing but n is a size of our array, we can say. So if array of we will compare with each and element with our target element. So array of 0 is equal to key or target element. So if it is matched, that means the key is found. We can stop the searching. But if the here the element is not found with the first index element, that is 7, then we have to compare with the next element, that is 3. So if it is matched with 3, then we will stop, otherwise we will continue with the next element. Like that we have to repeat the loop. If the end of the array is reached and the element is not found, display element is not found, and finally we will stop it. This is the algorithm of linear search. Now with one example we are taking here. Here the array is 2, 3, 4, 7, 1, 5. So this is our array and these are the index values 0, 1, 2, 3, 4, 5. That means here the elements, the number of elements in the array are 6. That's why the array index last index will be 5, that is size minus 1, that is 5. So here our target element is 7. That means we have to find whether the 7 is present in the array or not. If it is there, we have to return the index of that particular target element. Now in the first step, the index I will be set to 0. That is because array index will start with 0. That's why initially I am taking I value as 0. And now I am comparing with array of 0 with target. Array of 0, that is nothing but how much? 2 is equal to our target element, that is 7. 2 is equal to 7. No, condition is false. That means the target element is not found here. Then move to next index. So next index means I value will be incremented by 1. That is index value will be incremented by 1. Now array of 1 is equal to key. Just we have to check if array of I is equal to key. Array of 1 is nothing but how much? 3. So 3 is equal to 7. Is condition true? No, condition is false. Then move to next index. Then next index, like array of 2 is equal to key. So array of 2 is how much? That is 4. So 4 is equal to 7. Condition false. Then we have to move to next index. Now I value is 3. That is nothing but index value 3. Now array of 3 is equal to key. Just we have to check whether this condition is true or false. Array of 3 value is how much? Here 7. 7 is equal to 7. Yes, condition is true. Once the condition is true means the key value is found in the array. Yes, we have to write like element is found. So in which index the element is found? At index 3. That means the target or key element found in the array. So we have to return the index of that particular element and we have to stop the search. Why you have to stop the search? Because already we found the element in the array. Then no need to search remaining elements. That is the waste of time. So that is the time complexity is very important here. That's why I am stopping here. So the target element found at index 3 that we have to return. That is the result. Now if you see the example program here, so this is a Java example program. So here the program starts with the main method. So here we have taken the array 2, 3, 4, 7, 1, 5. The array name is ARR and the elements are these all things. And we have fixed one target element, target or key we can call like anything like target element or key element, both are same. The target element is 7 and here we are taking index value because we have to, the program has to return index value where it founds the target elements. That's why I am taking index here and the index value will be written in the form of integer data type. That's why here I have taken int index equal to search of array comma target element. In this search method I am sending array and target as the variables arguments. So when I call this method, it will move to this search body. Here, first it will take ARR dot length. What is this ARR dot length? This method returns the length of the array. So here the length of the array is nothing but total number of the elements in the array. Here the total number of elements are 6. That's why the n value becomes 6 here. So here n equal to 6. Now I am taking one for loop because if we are using arrays, then to search all the elements or to compare with all the elements, we have to travel each and every element in the array. To travel in the array for each and every element, we have to use any one loop. So here I am taking a for loop. So here int I equal to 0. Why I am taking I equal to 0 means here array index will starts with 0. That's why I have start with 0. And up to where I have to compare the elements means I less than n. What is I less than n? I value that starts with 0. Less than n means n is our length of the array, that is 6. I less than 6. I less than 6 means it will move up to 5th index. It will move up to 5th index. So 5th index is the last element. Already we discussed in the previous slides. So array index will end with size minus 1. That's why I have taken I less than n. So here first the condition will be I equal to 0. Yes, I is 0. I is 0 and I less than n. I value 0, n value is initially 6. 0 less than 6. Condition is true. When the condition is true, it will enter into for loop and it will execute this statement. Is array of I. Array of I means if ARR of I value is here, initial I value is 0, equal to our target is 7. It will check the condition. So array of 0 is 2. 0 index element is 2. 2 is equal to 7. Condition false. If the condition false, it will not return anything here. Just it will return -1 simply. So and it will go to, if it is not true, it will not return I value. Then it will go to I plus plus. That is I value will be incremented. Now I value becomes 1. So 1 less than 6. Again the condition will be checked. 1 less than 6. Yes, condition is true. If 1 less than 6 condition is true, again it will enter into the for loop. Again it will check array of I is equal to target. Yes, array of 1 is equal to target. Array of 1 is nothing but 3 is equal to 7. Condition false. Then again it will move to I plus plus. I plus plus means I value will be incremented by 1. Previous I value is 1. Now I value will be incremented by 1, that is 2. 2 less than 6. Yes, condition true. Again it will enter into for loop. Again it will check the condition. Then 4 is equal to 7. Condition false. Then again I value will be incremented. Then I value becomes 3. 3 is less than 6. Yes, condition 2. Then array of 3 is nothing but value 7. 7 is equal to 7. Condition 2 and it returns I value. So when it is returning I value, if the condition is true, then only it is returning I value. So I value is now 3. That means our output will be 3. Our output will be 3. So this is about the linear search program and how it is working. Simply it will starts with the beginning of the array and compare each element in the array, and if the element is matched with the target element, then it stops the searching and it will return the I value, index value. Otherwise it will move to next index position value. So it will continue up to end of the array. Once it reaches to end of the array, but if not found any element, simply it returns element is not found in the array. Next one is binary search. So basically, linear search is very simple. When compared to linear search, binary search is somewhat complex. But why we have to prefer binary search means in linear search, the time complexity is very high. Because just take simple example. For example, I have 10,000 values or 1 lakh values in my array. 1 lakh values in my array and my target element is at last position. Then what will happen? It has to compare with all 1 lakh elements. Just assume how much time it will take. That is the main drawback of linear search problem. When we are using large arrays, then the time will be it will take very much time to find the element. So if the element is at the beginning of the array, then it is okay. It is simple and it will return immediately. But if the element is in last position, then it will take more time. That's why next we are moving into binary search just to reduce the time complexity. So in the name itself, we can see binary search. Binary search. That means by means 2. That means the array will be divided into 2 in each and every step. Just see here, binary search is an efficient searching technique used to find the element in a sorted array. Here the main point is sorted array. In linear search, the linear search technique can apply either in sorted array or unsorted array. But coming to binary search, we can apply this binary search only on sorted array. If the elements are not sorted, first we have to sort the element by using any sorting technique. After that, we have to apply the binary search. Here, the work is repeatedly dividing the search space into 2 halves. In binary search, the middle element of the array is compared with the target element. If the middle element is the key element, then it stops the search and it will return the index of the middle element. Otherwise, it will check whether the middle element is smaller to target or it is greater than to the target element. If the middle element is smaller to target element, then the search will continue in the right side. If the middle element is greater than to the target element, then the search will be moved to left part of the array. So here, this is the algorithm. We will start with one sorted array. That is the main thing here. We have to fix one target element. And here also same thing. The low, we have to take low and high. So low value will be always 0 because the array index will be starts with 0. And high value will be always size minus 1. That we can say it as a n minus 1. Here size, I am using size or I am taking the entire size of the array as n. That's why I am using n minus 1 here. We have to repeat here. First, we have to divide the entire array into half parts, 2 halves. That we can say we can divide with a simple formula: low plus high by 2. Then it will be treated as mid. Then we will compare with array of mid is equal to target or not. Array of mid is equal to target. If array of mid is target element, then simply we will stop the searching and we will send the index position. If target is less than to the array of mid, that means it will be in the left side. So then high value will be changed to mid minus 1. If target is greater than to array of mid, then low value will be set as mid plus 1. If element is found, we will return the index. Otherwise, it will return like element is not found. We can stop. So here we are taking one array, same 2, 3, 4, 7, 9, 10. This is our array. And here index positions are 0, 1, 2, 3, 4, 5. If you observe clearly, this is sorted array. Remember, if you want to perform binary search, the array should be sorted. So here I am taking low equal to 0, high equal to 5, that is size minus 1. The size is 6, 6 minus 1, 5. Now first step, in the first step I have to find middle value, mid value. Mid is equal to low plus high by 2. That is 0 plus 5 by 2. That is nothing but, we can say it as a 2. That is mid equal to 2. So mid equal to 2 means this is the mid value. Now we have to compare with the array of 2. That is array of 2 is equal to our value, target value 10. That is 4 is equal to 10. Condition is false. Once the condition is false, then we have to check one more condition, whether the mid value is less than to the target or greater than to the target. So once you observe here 4 is less than to target. That means our target element is 10 and our mid value is 4. So simply you check, observe here, mid value is 4, target value is 10. That means if you search with, if you compare with 4, and if you clearly observe, the mid value is 4 means left side part of this array should be less than to mid value. That is less than some 1, 2, 3, something like will be. That means this part of the array should not contain our target value, because our target value is greater than to mid value. That's why we can omit this part of the array. Now our new part, we can omit this 4 also, because already we compared our target element with 4. So simply our new array will be 7, 9, 10 only. This is our new value. So if you clearly observe, what changed here? Here high value is not changed. High value is always 5. High value is not changed. This is high only. It's not changed. Coming to low, previous low value is 0 index, that is 2. But now we are omitting or we are removing this part of array from the searching. So we have to change the low value. We have to change the low value. How to change the low value? The condition for changing the low value is then we have to set low equal to mid plus 1. So what is our mid value? 2. Now low will be mid plus 1 means 2 plus 1, that is 3. That means this will be our low value. Now this is our new array. Now we have to repeat the same steps. Again we have to take mid. So again if you take mid means mid equal to low plus high by 2. Then you take here this low means what is the index of this low? That is 3. And what is the high of index of high? That is 5. 3 plus 5, that is by 2. That is 8 by 2. That we can say it as 4. That means our new mid value is 4. Mid index value is 4. Then you just say that is 4. Now we have to compare area of 4 is equal to target or not. Area of 4 value is 9 is equal to 10. The condition is false only. Again, now you have to compare, you have to take one more condition, whether the mid value is less than to target or greater than to target. If you see here, the mid value is less than to target. If the mid value is less than to target, then which side we have to move? We have to move right side. Our previous array is 7, 9, 10. Here this is the mid value. Now we compared with mid value and our target value is greater than to this mid value. Then we can remove or we can omit this part of the array from the search chain. We have to take only right half. That is, the index is only 10. The next array is only 10. Actually, this is the high. There is no change. The index is 5 and this is the high. Now, what we have to change? We have to change the low value. So, if you want to change the low value will be changed with low equal to mid plus 1. Our previous mid value is 4. Now, mid plus 1 means 4 plus 1, 5. That means both low and high will be at only one element, that is 10. Again, you have to perform the same operation, that is low plus high by 2, that is 5 plus 5 by 2. Here both low and high are pointing to the same index position. That's why 5 plus 5 by 2, that is 5. That means now mid equal to 5. Now we have to compare area of mid is equal to target. Area of mid value is now 5 equal to our target value is 10. So area of 5 means the value is 10 only. 10 is equal to 10. Yes, condition true. When the condition true means our target value is found in the array at index 5. So 10, that is target element is found. Simply we have to return the index. Which index we have to return? Mid index. That mid index is nothing but 5. So once the element is found in the array, we can stop the search. Now this is the program for searching. So this is the technique what I have explained here. First we have to check whether low is less than or equal to high. If the condition is true, then we have to go for low mid equal to low plus high by 2 or low plus high minus low by 2. Area of mid is equal to target. If it the value is the condition is true, then simply return mid. Otherwise we have to check area of mid is less than to target, then low value will be changed. That means right side part of the array we will consider. Otherwise we will take left side part. If you take left side part means high value will be changed. High equal to mid minus 1. This is a simple flowchart for this program snippet. Now initially I have taken this array and we have to take array length and our target is 10. Low value is always 0 and high we can take here high n minus 1, we can take n minus 1. If you take high equal to n, then we can use this one I minus low. So both logics are correct only. And we have to call this method binary search. We are sending entire array our target value, low value and high value also we have to send. And if it founds, it will return the index values. Now what are the differences between linear search and binary search, and which one is a more efficient algorithm? So in linear search, both the input data need not to be in sorted order. So we can take both either like unsorted array or sorted array. Coming to binary search, here it is mandatory to take sorted array for applying binary search algorithm. So it is also called, the linear search is also called as a sequential search. Coming to binary search, it is also called as half interval search. Time complexity of linear search is big O of n. What is this big O of n? So already I have explained in linear search. For example, if you have 1 lakh elements in the array, then in worst case situation, the worst case situation is nothing but our target element is placed at the end of the array. That means from 0th index to 99,999th index also we have to compare. Up to that index we have to compare each and every element. That means how many comparisons we are doing means 1 lakh comparisons we are doing here. That means that much time is wasting in linear search. That is the main drawback in linear search. That's why big O of n. What is n here means n is nothing but size. If you have 1 lakh means that is like a big of 1 lakh times comparisons we have to make. That is the main drawback in linear search. That is the time complexity. Coming to time complexity of binary search, it is a big O of log n. Why we are using log n here means here every time we are dividing the array into 2 parts. So in the initial stage, we are dividing it into 2 parts. 1 lakh elements will be divided into first 2 halves. 50 lakh elements, left part, 50 lakhs elements, 50,000 elements, 1 lakh, 50,000 elements in second part. So we will compare with mid value, and based on the target element, we can omit either left side 50,000 elements or right side 50,000 elements. We cannot. So with the remaining 50,000 elements only, we will perform the searching. Again, that 50,000 elements will be divided into 25,000 elements and 25,000 elements. Again, we will check the mid value and we will go with any one part, either left part or right part of the array. So 25,000. Again, that 25,000 will be divided into 12,500 and 12,500. So that means every time the array will be dividing, so it is becoming a half of the total elements. That means here the time will be very less. It will take very less time. That is big O of log n we are taking here. So coming to linear search, multi-dimensional array can be used. So like we have different types of array, like one-dimensional arrays, two-dimensional arrays, and multi-dimensional arrays. So we can say this two-dimensional is also multi-dimensional. One-dimensional means what I have shown here, that is with 0, like 0, 1, 2, 3, 4, 2, 5, 1, 4, 6. This is one-dimensional array. The elements will be in only one-dimensional. Coming to two-dimensional, the array will be in matrix format, and it is nothing but rows and columns. Here the elements like 0, 0 index, 0, 1, 1, 0, 1, 1. Because this is 0th row and first row, 0th column and first column. That's why this element will be represented or indexed as 0 and 0. This element will be represented as 0, 1. This element will be represented with 1, 0. This is row and this is column. This will be represented as 1 and row. So if we are performing a linear search operation, so no need to bother about dimensions of array. Any dimensional array you can take, multi-dimensional array or single dimensional array, any array you can use. But coming to binary search, we can use only single dimensional array. Why we have to use only single dimensional array in binary search means here, if you observe clearly in binary search, what we are doing, the entire array will be divided into 2 halves. So if you want to perform the 2 halves and these all things, we have to consider those index values also. That's why previous we have taken as a low equal to 0, high equal to some size minus 1. So if you are going with multi-dimensional array, that splitting is not possible. That's why binary search will be performed only on single dimensional arrays. So coming to linear search, it is less complex. Yes, obviously it is very simple searching technique because nothing new here. Simply what we are doing, we are comparing with each and every element in the array. If it is found, simply we are stopping the searching and we are returning the value. Otherwise, we are continuing up to end of the array. So there is no any any loops or any other partitions, these all things. That's why it is very simple, less complex when compared to binary search. But coming to binary search, it is more complex. Why we are saying more complex means every time we have to partition the entire array into 2 parts, 2 subparts. We have to change either high value or low value. That's why we are saying it is more complex. It is very slow process, linear search. Yes, it is very slow process. Each and every value I have to compare we have to do. Later, the index value will be moved to next element. That's why it is very slow process. Coming to binary search, it is very fast process because entire array will be divided and we will check some element, our target element, whether it is found. Okay, otherwise we will check whether it is greater than or less than to made, and we will further divide it into that array. That's why it is very fast. Thank you.